All right. Okay. Can you hear me? Okay. Can we start? Right. Okay. Can we start? All right. Can we start now? Okay. Can we start? Yes. Okay. Can you hear my voice? Okay. Can you hear my voice? Right. Can you hear my voice? Sorry. All right. Okay, I hope you can hear my voice. Okay. Okay, okay, one, Tingli. Okay, low, Jinyi. Okay, you solve. All right. Okay, you solve. All right. Thank you very much. All right. So now I share with you. I send the QR code at your Telegram. Now I want to share. Okay, I stop sharing. I share. Okay, my notes here. I put the today class is a Newton. All right. Okay. Wait for a while. I want to open what we learned last time. Newton divided different method. All right. Newton divided different method. Right. I share with you. Okay. Mm-hmm. Okay. Windows. Okay, Newton divided different formula. Okay, from here, you can see here, all right. Okay, what you see is, I close here, I focus this note, all right. So I focus. Okay, you learn about the Lagrange interpolation and Lagrange interpolation and Newton divided. Okay, we learn about Newton divided. Okay, using Newton divided. Okay, Newton divided. You need to divide with the any number with the data on the previous. All right. So this is the way how you divide. Okay, this is the way how you write the table for the Newton divided different interpolation polynomial method. All right. For example, if you want to find E is a okay y 0, 1, 2, y2 minus y1 order 1 divided by x3 okay, minus x1. All right, to get E, all right, you need to follow this formula. All right, and then if you want to find C is a y2 order 1 is a y3 minus y2 order 0 divided by x3 minus x2. You just use this table. All right. So I teach you how you get the answer from the table. And then after that, after completing the table, you need to write polynomial using Newton divided P3x. Okay, okay, the formula still remember what is the formula? All right, y naught 0 plus y naught 1 x minus x 0 plus y naught 2 x minus x 0 x minus x1 plus y naught 3 x minus x 0 x minus x1 x minus x2. What is y naught? Is the first line for the first row, y naught 1, y naught 2, y naught 3. All right. So this is the formula. You fit all the value. You can get ln 1.2 is 0.1816. However, ln 1.2, when you press the calculator, is a 0.1823. So the error 0.007 is the absolute error, shows that Newton divided is not too much converged to the exact solution. All right. So now, okay, I want to go to the next step. Go to the e-learning. All right. I share with you now. Okay. Stop sharing. share with you the file, okay, the web file. Okay, you go to the e-learning. Okay, this is e-learning. Share with you. Okay, e-learning. Okay, from the e-learning, you can see here. Okay, 2393. Okay, what I insert in the e-learning, the first is I give you a link. Okay, I give you a link using Google Drive. I already accept your invitation to access this link. All right, if you click, you can get a video. All right, you click, you can get a video. And then, okay, for the today, I send you notes, okay, on the Newton forward and Newton backward different interpolation polynomial in PDF file. And then I'm also insert the link, okay, for my class previous, okay, on the Newton divided different interpolation. All right. So, I want to watch, okay, this video on the Newton backward and Newton forward. All right. So, okay, I stop sharing. Okay, I'm stop sharing here. Okay, I hope I can go to this. All right. It's a Newton forward and Newton backward different for me. All right. So let's we go. Okay, before that, okay, I just want to confirm. Okay, okay, that's I sharing. Okay, stop sharing. Okay, I go to the video. Where is the video? Backward, forward. All right. Okay, it's very clear now. Okay, let's we go to this video. I make it more bigger for you to see. All right. Okay. Now, what is a Newton? Okay, what is a Newton forward and Newton backward different for me? All right. So now, from here you can see that we know about the types of data. It's a uniform and non-uniform. The uniform data we can solve using Lagrange interpolation and Newton divided, right? Because not uniform. The H, okay, the size of interval is not similar. Okay, but now, all right, we are using interpolation, solving a data using interpolation, but the data is a uniform. Okay, is a uniform, means that the size of interval between x1 and x2 is similar, x3 and x4 is similar. So the data is uniform, means that you take the water level, okay, for every day. Okay, you find the how many rainfall every day, because there is no the interval is similar every day. All right. So now, okay, since we are learning about the data in the uniform, all right. So now, let's we continue. Okay, let's we continue. Okay, there are two types of formula for us to solve interpolation with uniform data. The first is Newton forward. Okay, the second is Newton backward. All right, we learned already Newton divided. All right. So the rest is a different interpolation polynomial, is the words that you need to follow after the method. All right, so now I just want to remind you, before this we learned the data is a non-uniform, and then we use Newton divided different interpolation method, all right, for solving the interpolation type for writing the formula and finding the missing data. All right, so let's now focus on the Newton divided different formula. We want to find y not 0, y not 1, y not 2, y not 3 if the data is order 3. Right, we are given already y naught, x naught, y1, y1, x1, and so on. So the problem now, how we want to create the triangle forward above. All right, so this is important. And then we divide the x, okay, for the specific point. So I already teach you, okay, the triangle is based on the forward above. All right, for example, you want to find y 1, 2. Okay, y1 order 2. So it's depend on the y3 1 minus uh, y2, okay, y2 1 minus y1 1 divided by how to get the x3 minus x1, because you can see the root of y3 and y1 is based on x3 and x1. Look at the table. Okay, look at the table. You can see this one is a x3 minus x1. This is a formula that I will already write, but this is the way how we want y1 2, where it depends on the data from the previous. So the same terminology, we want to solve the data using a Newton forward and Newton backward different, okay, interpolation. All right, the data is non-uniform for the previous, but the data for this time is a uniform. So you see, for Newton forward, you still develop the triangle forward above, but not divided. Meaning that if you want to find y not 1, is depend on the y10 minus y00. All right, so no divided, because you are using the same h x0, x1, x2 is similar. For backward, okay, the triangle you need to develop is a backward, okay, backward down, okay, down. Okay, you are using backward but down. All right, so you want to find the value y3 not, y30, y31, y32, and y33. All right, so you use the n is a 3. All right, for forward you use y not 0, y not 1, y not 2, y not 3. 3 is a degree, the order. So now, why we learn Newton forward, Newton backward? We learn Newton backward and Newton forward because, okay, why? Because we want to get a missing data for the early data near to x0. For backward, okay, we are using to find a missing data where the data is near to xn. All right. So this is why we learn Newton forward and Newton backward. So now, my question again, why we need Newton forward? This is my question. Why we need Newton forward? The second is why we need Newton backward. Okay, Newton backward, different interpolation polynomial. So these are two questions that you need to guess now. Okay, we need forward because we want to find a missing data near to x0. Okay, near to y0. All right, we are using backward, okay, because we want to find the data near to xn. Xn here is a 3. All right, so again, I want you to remember. All right, when we are going to use x0 and Newton forward and Newton backward. All right, so now let's we continue. Okay, let's we continue. Okay. Okay, so now how to generate, how to get the formula from this table, for example, to find Newton forward and Newton backward. All right. Okay, so in this case, okay, we are applying Newton, okay, polynomial. We still applying Newton polynomial. All right, the formula that we use for Newton divided. Okay, let's we introduce you, okay, the formula, okay, the notation of triangle, okay, the triangle, the forward triangle, that's we call as a forward different. The other one, the back one is the other notation is a backward different. All right, so make sure that there is no divided involved, because x0 minus x1 equal to x1 minus x2 and so on. So we know already, okay, we know already yi for degree 0 is a given in the question. It's a del forward del 0 yi. All right. For the high level, okay, high order, okay, del k yi is a del k minus 1 yi plus 1 minus del k minus 1 yi. What is del that I told you before is a, you go to the forward, is here, is a yi0, yi1, yi2, yi3. That is, but we are using del. Okay, why we are using del, delta, different, forward different, to make a difference between forward and backward. All right, again, yi, okay, given data is a del 0. Okay, yi for order k is a del k, is a yk minus 1, yi del k minus 1 yi plus 1 minus del k minus 1 yi divided, there is no divided here, right? Because there is no divided here, right? So now we want to create the formula. We start from y naught 0 equal to y naught. Okay, this is a value. All right, but we are using del not y naught. All right, so no del, but we put del because to make sure it's different with the backward. So y1 order 1 is equal to y1 0 minus y naught 0 divided by h. H is familiar. So we can put as a del 1 y naught divided by h. This is how I create the formula. All right. So next is y naught 2. Okay, y naught order 2 is a y1 order 2 minus y naught order 2 divided by x2 minus x naught. All right, that is equal to, I make it more simplest. Okay, make it more simplest writing by replace y naught order 1 to the next equation. You will get 1 over 2h squared del 2y naught. All right, so now, okay, for y naught k, for other k is an order k, is a table, is very much, the size of data is k. So this is the formula for Newton forward. 1 over k prime, h prime, delta k, okay, y naught. All right. So my question here, all right, my question here, what is, what is k prime? What is k prime? I know most of you know that, okay, what is a k prime? K prime, okay, if I put k prime is equal to, all right, for example, I put a 3 prime, okay, or 4 prime, or 5 prime. So it's a 4 times 3 times 2 times 1, factorial. We learn about factorial. Okay, for example, K4 factorial is a 4 times 3 times 2 times 1. If 3 factorial, 3 times 2 times 1. All right, so we learned already about factorial. Okay, so now, I continue. Okay, because I want to create, okay, the formula for finding the Newton forward different interpolation. Okay, we know already what is y naught k. Y naught k is important. Yeah. So in this case, okay, I want you to know about the what is k, what is h, and what is r. So I give you some information here. All right, x equal to x naught plus RH, okay, is a next value x, okay, x naught plus r is how many times, okay, to get x from x naught. H is a size of interval. So for example, x1 is x naught plus 1h, x2 is x naught plus 2h, x3 equal to x naught plus 3h. This one is, remember, h is a how many times, okay, for x naught to reach x. All right, h is what? Is a size of interval. Size of interval between x naught, x1 is equal to x2 and x3. This similar, that's we call as a uniform data set. All right, so the second is, if I say x minus x naught, x minus x1, x times x minus x2 times x minus x3, meaning that r minus 1, r minus 2, r minus 3 times h power 3. All right, so this one is a some argument you need to remember, because we want to create the Newton forward, okay, divided interpolation. All right, so the formula for Newton forward divided interpolation, or I said that Newton forward, okay, di is a divided interpolation, is can write as a P and X, okay, P X naught plus RH, R already you know, all right, N is a number of data started from X naught up to Sn, R is how much, okay, value, okay, interval to reach X, okay, from X naught. H is a size of interval, okay, many times I explain this one. So you can put here R delta Y naught, R minus 1 divided by 2 factorial, delta, okay, is a forward difference squared Y naught. All right, so in this case, you can see here that delta squared, delta power 1, and Y naught is a delta 0. All right, so I just write for the simplest here, delta 1, delta 2, delta 0, plus, because we need to continue to R minus 1, R minus 2, R minus 3, okay, times R minus N minus 1 divided by N factorial. Divided by N factorial times del N Y naught. Okay, okay, del N Y naught. If I want to stop N equal to 3, I can use this formula. If I want to stop N equal to 4, I can use this formula. All right. So now I can simplify, okay, because I'm using plus many times. I do summation RK delta K divided by Y naught. What is RK? RK is a factorial. What is R? R is a X minus X naught divided by H. All right. So this one is, you need to remember. You will use this one. All right. So this is the formula for the Newton forward, okay, at different interpolation. All right. So now I give you some example. Before that, I want to stop here. I want to, all right, ask a question here. All right. So since we know what is a Newton forward, okay, what is the step, okay, to solve the missing data using Newton forward? Okay, Newton forward. Okay. So I said different interpolation. All right. I don't want to make. I just want to make it short. I said, what is the step to solve the missing data using Newton forward difference interpolation? This is my question. Okay. So the first, as usual, using Newton divided before, we need to create a table. Second, we need to apply the formula of the summation RK del K Y naught. All right, we need to apply and then replace X to the missing data, you can get Y. All right, so there is two steps. Just use the table. Second, replace to the formula P and X, and then replace X equal to the missing data. It's very simple. All right, so now we continue. Okay. So now let's say I giving you a data. Okay, the data is depend on the ln x. Okay, ln x for 1 is 0. Ln x for 1.2 is 0.1823. Ln 1.4 is 0.3365 if I'm using 4 decimal places. Ln 1.6 is 0.47 and ln 1.8 is 0.5878. All right. So I want to use Newton forward different interpolation to solve, okay, my problem. Okay, the missing data here is 1.1. So since 1.1 is near to the 1.0, okay, where is 1.1? Is between 1.0 and 1.2. So you can use Newton forward. All right, so I stop here. Okay, I stop here. I want to ask you, when we are using, this is my question, when we need Newton forward. Okay, when we need Newton forward, the answer is we need the Newton forward when the missing data is near to x naught, is near to the x naught, we are using forward. Okay, if near to the xn, for example, near to x equal to 1.8, all right, we are using backward. For example, I want to find the value of ln 1.7. So I need to use backward. All right. So when we are using forward, because the missing data is near to the x naught. Be careful, okay, because this is a common question during the final exam. All right. So now, all right, so I go to the finding the Newton forward for ln 1.1, and then the second question is what is R? You need to find what is R, what is H, all right? What is the ln 1? I want to find ln 2.4. What is the ln 2.4? So in this case, you need to find the function P P and X. So what the value of N? 0, 1, 2, 3, 4. You have 4 data. All right. So you need to find P for X. Okay. P for X. What is R? What is H? H is a 0.2 because 1.4 minus 1.2 is 0.2. All right. So in this case, what is R? R is, if you want to find 1.1, so you use the formula. What is the formula? X equal to x naught plus RH. So R is a x minus x naught divided by H. All right. So please remember, this is a common formula, basic formula. All right. So what is H? I stop here. I want to find what is H. What is H in this data? All right, can you answer me? Can you send me the answer? For example, low 1, you solve, Rifat, okay, you solve, all right. So all here, okay, what is H? Okay, what is the value of H? Come on, can you answer? What is H here? What is the value for H? Come on, can you answer the question? I'm waiting from the rest. Register to the YouTube. You can answer at the top chat. All right. What is a H? Yes, 0.2. Very good one. Very good you. So because the data is a uniform. All right. So now I want to continue. I want to continue again. All right. So now I go to the answer. The first is, okay, as usual, you need to generate the table for Newton forward. Second is, all right, you need to use the formula for P for X, okay? And then during that, you need to find R and H, all right? This is a common, all right? And what is the P1.1, all right? P4 in our case. Come on, let's develop the table, and then press your calculator to mode fix 4. All right. Okay, now I want to, I'm not miss the data, so I bring down, okay, because I can refer what is a y naught. Okay, from the data, you can see the y naught is a 0, y1 is 0.1881823, y2 is 0.3365, y 1012, y3 is 0.47, y4 is 0.5878. All right, so we have the data here. So now let's develop a table of a Newton forward. It's same as Newton divided, but you no need to divide. You just minus the value of y for the different step. Okay, delta, I put delta because Newton forward divided, okay, forward different. So there is a degree 0, 1, 2, 3, 4. All right, the data is a x0, x1, x2, x3, x4, y0, y1, y2, y3, y4. It's a given in the table. You refer to the table in the question. All right, so this is a Newton forward because you want to use Newton forward. The delta should be forward. Okay, the difference should be forward different. Forward different. Opposite of forward different is a backward different that we are going to learn after this. The degree, okay, the order is start from delta 0, delta 1, delta 2, delta 3, delta 4. For Newton forward, be careful. We want to find delta y naught, delta y naught 2 order 2, delta y naught order t 3, delta y naught order 4. That's we want. The first row, we want to concentrate on the value of first row. So the same thing, same as Newton divided, you minus y1 minus y naught is a 0.1823, y2 minus y1, all right, is a y2 is 0.3365 minus 0.1823. All right, so I put in the value very easy, A, B, C, D, E, F. All right, J, A, B, C, D, E, F, H, I, J. All right, because from here you can see that you want to find the value of A. A is a Y1 minus Y0. B is a Y2 minus Y1. C is a Y3 minus Y2. D is a Y4 minus Y3. There is no divided. Hey, F is a C minus B. I is a G minus H. What is G? G is a delta order 2 Y, Y2. Okay, Y2. All right. What is J? J is a delta order 4 Y0. So we are focused to find A, E, H, J. All right. Y0, delta Y0, 1, delta Y0, 2, delta Y0, 3, delta Y0, 4. All right. So we continue how to find, okay, A, B, C, D, E, F until J. A1, I told you, Y1 minus Y0. We know already Y1. We know already Y0. B is a Y2 minus Y1. We know already the value of Y2 given in the question and Y1 given in the question. C is a Y3 minus Y2. All right, it's also given in the question. No need to do a divided because this one is a Newton forward. Why? Because H is a similar 0.2. And then D is a Y4 minus Y3. E is a B minus A. What is a B? B is a Y1 order 1 minus Y0 order 1. All right. So what is a E is a negative 0.02. This is the negative value. Okay, I drag on the left to make sure that I can put 207. Okay, F is a C minus D. All right, so because I'm using these types of the triangle forward, all right, what is G? G is a D minus C. All right, and then next we want to focus on A, E, H, J. All right, the first row. Okay, F is a negative 0.027. F is similar to, okay, come on. Okay, it's a similar to F as C minus D. All right, and H is a F minus E, and I is a G minus F, and J is a I minus H. All right. So just minus, no need to divide. All right. Very easy. Be careful for using Newton forward different formula. Remember the formula. Bring the formula down. Why? Because we still not remember the formula. Put the left. Okay. Still okay. You need to remember when n is equal to 4. So P4 equal to P4 x naught plus RH. You know what is R and you know what is H. H 0.2. R is depend on X. All right. So why not? What is the formula? Okay. What is wrong of this formula? All right. You see there is a wrong for this formula. Okay. What is the wrong? What is the wrong of this formula? What's wrong of this wrong? What is the wrong? Okay, what's wrong of this formula? All right, so the wrong is a r minus 1 divided by 2 factorial plus r minus 1, r minus 2, all right, because we have 3 factorial above. We need to go to up to the 3 factorial. You know that what is wrong? You need to times r minus 2 divided by 3 factorial. So that is a wrong, all right? So now, okay, what is wrong? The wrong is okay, r minus 1 divided by 3 factorial, okay, times r minus 2, right, times del 3y naught plus, what is wrong of this formula, all right? Okay, can I know what's wrong with this formula? Okay, come on. What's wrong with this formula? Okay, so my question, what's wrong with this formula? The formula is should be r minus 1, r minus 2, r minus 3 divided by 4 factorial delta 4y naught. All right, delta 4y naught is a j. All right, so you need to use the table that I give you, okay, del 1, del 2, del 3 till del 4, all right? So that is the wrong of this formula. The second is 4 factorial is a 4 times 3 times 2 times 1. 4 times 3, 12, okay, times 2, 24, times 1. Okay, 3 factorial is 3 times 2 times 1. All right, good. I love you. All right, thank you, Liu. Thank you very much. Very good. So this I miss. Okay, I miss the formula. So come on. Okay, the formula is above there. So I need to continue and then I need to correct the formula. Come on, I correct the formula, write the formula. Okay, okay. I want to find when x equal to 1.1 near to the table. Okay, so near to 1.1, I need to use forward. So R is, still remember, yeah, formula of R is what? X minus X naught divided by H. Okay, X is 1.1. Okay, 1.1 here in the table. Okay, H is similar for every size of interval 0.2. Okay, H is xi plus 1 minus xi. We learned already from the previous data. Okay, so 1.1, so I realized that the formula is wrong. Okay, 0.5 delta 1y naught is 0.1823. Okay, is a A, all right. And then r minus 1, 0.5, 0.5 minus 1 divided by 2 times negative 0.0281, all right. So the other one, okay, please correct the formula. 0.5, 0.5 minus 1, 0.5 minus 2. All right, this is wrong. Okay, you need to find minus 2. All right, come on, because the formula is minus 2. Correct the formula. Okay, 0.5 minus 2. And then 0.5 minus 3 divided by 4 factorial. Just now is a 3 factorial. Okay, this is the value of the delta. Okay, this one is a delta 3. Okay, y naught. This one is a delta 4 y naught. Okay, so when we use your calculator, you will get ln 1.1 is 0.0952. So I stop here. When you press your calculator, what is a ln? Press your calculator. 1.1. Can you press your calculator? Is it similar to 0.0952? So is it similar? My question, similar or not? Similar from the Newton divided and the formula that you get from the data, okay, from the Newton forward is similar? Or if that is not similar, can you find the absolute error? Can you find the absolute error? Oh, similar or not similar? 0.0. Okay, similar, yes. Absolute error? Okay, I got 0.0953. So you have an error. So the absolute error, how much? 0.0002. All right, the error is what? The error is 0.1232. All right, because 5 2 you get 5 3, so 0.01, 1% ke tu, not 1%, below lagi kan, is very low. It's a 0.0001. All right, the difference is between 001, means that Newton forward, okay, is more much okay, accurate compared to the Newton, okay, Newton divided. Why? Because Newton forward using the same H. All right, so that's why the answer is much better. All right, so you can see here, okay, what is your conclusion? Your conclusion is the error is very small. All right, what is your conclusion? We want to go to find P4 2.4. P4 2.4, don't worry, okay? You just replace X for P4X. You replace 1.1 by 2.4. And then you find the error. Okay, where is the formula? We have a P4 in the previous step. This is a formula. Replace X, okay, to the 2.4. Okay, you can replace here. You can get the answer ln 2.4. It should be near to the calculator ln 2.4. All right. So I hope, okay, you can try, okay, your exercise here. Find, okay, my question is how accurate ln 2.4, okay, and Newton forward, different interpolation. So this is my question. For ln 2.4, can you replace to the formula? And then I want to find the error. How much the difference between ln 2.4 from your calculator and then ln 2.4 from Newton forward different interpolation. So I want to find. All right, should be okay. I think the error should be like 0.001 or less than 0.005. All right. Okay. So now my question: what is different? This is my question. What is the different between Newton divided, okay, and Newton forward? Can you write here? Can you write your answer here? Okay. There are so many different. I just want one. What is the difference between Newton divided and Newton forward? Can you answer my question before I go to Newton backward? Right? Can you find the answer? Come on. I'm waiting for you. I'm waiting. Okay. I'm waiting. Okay, we want to go. What's different between Newton forward and Newton backward? So come on. And Newton divided. Okay, Newton divided. Can you, okay, find any answer? I'm waiting for you for the answer. I want to get the answer. What's different between what you learned before, Newton forward and Newton divided? Okay, Newton forward and Newton divided. Any question? There is no question. I'm waiting. What is the difference between Newton divided and Newton forward? The important things. Can you find the important? The important is what? What's different? The important. Okay, what's the important? I just want to find the important. Okay. What's different between Newton forward, Newton backward? The important is, I love to write this answer from wantingly. Yes, Newton forward is uniform. Newton divided using non-uniform data. Very good. And then from Go Kian Wei, Newton divided for not uniform data space. Newton forward for uniform data space. Very good. Thank you very much. All right. Thank you very much. So let's we continue. Let's we continue our class to the Newton backward difference formula. Okay. The same thing. We want to apply the same example, but the way we train the data, is a backward down. Okay, backward just now is a forward above, but now backward below. Okay, backward below. All right. So how we want to create the Newton backward difference interpolation? The first is we know already. We start from n. We not start from y naught, because Newton backward is to find data missing near to xn, near to yn, near to the last data. All right. So we start from n, the last data. So y naught n is a yn 0, degree 0 is a yn. It's a given in the question. All right, is a given. So okay, we call this one as what? We call this one as a backward difference. Okay, the data, the way I writing is different. Backward. Okay, come on. You want to see the way how I write is not like Newton forward. Okay, Newton forward is different. This one is a Newton backward. Okay, Newton backward is what? Is a opposite sign different from Newton forward. Newton backward different formula, they are emphasized on the last data. So n is a last data. Y naught, okay, yn 0 is a yn equal to del, okay, backward 0 yn. So this is given in the question. Yn is a backward degree 0 yn. But now I want to find yn degree 1 is a 1 over h backward different yn. Yn minus 1, yn minus 2, okay, in the order 2 is a 1. Okay, let's we continue. 1 over h, okay, backward del squared yn, not squared actually, order 2 divided by 2h squared. All right, so the way I write is an opposite sign from the forward different formula. So I create one formula is a yn minus 1 order k is a 1 over k factorial h factorial backward different k yn. What is a k? Your order. What is n? The size of interval. What is h? What is h? Size of interval. What is n? Number of data. All right. So again, okay, we already know the formulation based on the Newton forward before. So we know already x is a xn plus rh. Okay, x is a xn plus rh. All right. So now we want to find the r is between negative n and 0. Actually, xn minus rh kan ke belakang patutnya. Alright. So xn minus n, x minus sn minus 1, x minus sn minus 2, up to x minus xk is equal to r plus 1, r plus 2 times r plus 3 times r plus k, all right, times h power k. This is the way how we write if we want to write in the Newton, okay, divided formula, Newton polynomial style. So the formula for Newton backward different interpolation is p and x equal to pxn plus rk. What is that? It's a pn plus r backward del yn plus r plus 1 divided by 2 factorial del power, this one is power 1 power 2 yn and then plus r plus 1, r plus 2 divided by, okay, this one is r n minus 1, so it should be divided by n minus 1, delta n y n. All right, this one should be delta power 2, delta 2. So we give you some example. For example, y n plus rk. So the formula can write as r plus k minus 1 k, okay, times back del rk y n. K is between 0 up to n. All right. So what is r plus k minus 1k? This is my question. So we learned already that is a r plus k minus 1, r plus k minus 2, r plus k minus 3, okay, divided by, okay, 3 factorial lah. Okay, in our case, we need to continue to r divided by k factorial. All right. So what is a k factorial? 2 factorial, 3 factorial, 4 factorial is a, kalau you have 5 factorial is 5 times 4 times 2 times 1. All right. So that is a factorial. Okay. So now let's we go back to our example. Okay. We learned already example. All right. And then before this, we are using r minus k. But in our case now, it's r plus k. For forward, we need to have a different sign. Okay, different sign. Just know the formula. Okay, if you not remember the formula, refer to the table. If not remember the formula, it's refer to the table. All right. So now let's we continue. Okay, this is a table you need to remember. For example, that I told you. Okay, it should be backward below. Backward below. The emphasize here, you want to find y, because n is 3, y30, y31, y32, and y33. All right, 3 is order. All right, n is a 3. All right, so the way we write is a backward and below. Right. Okay, the process is a minus. Okay, the minus is familiar that you learn from the Newton divided, Newton forward. All right. The way you write of the triangle and the root is a backward below. All right. Giving the data, okay, I use the same data. Why? Because I want to compare. All right. The process to get the data near to the xn. All right. So this is a data given already. We know this using the same data. We want to find ln 1.7. Ln 1.7 is very near to xn, to x0, 1, 2, 3, 4, to x4. All right. So in this case, we need to use backward different formula. All right. Backward. That we want to find ln 1.7. Okay. Backward. Okay, is near to the 1.8. Before this is near to the x0. This one is near to the x4, y4. So in this case, okay, we have no choice. We need to use Newton backward different formula. So I stop here. So my question, when we need Newton backward, this is my question. When we need to use Newton backward. Newton. It's a Newton, bukan new. Newton backward. I'm not finished the writing. When? Okay, when we are using Newton backward. Okay, can you answer my question? When we are using Newton backward. Alright. Okay, why we not use Newton divided? Why we not use Newton forward? Alright, because Newton forward to find the missing data near to the x0. Newton backward is near to the xn. Good. Xn. The last, okay, grid you need to find using Newton backward. Very good. Piravan. Thank you very much, Piravan. All right. So, okay, xn. Very good. Sn. Okay. Sn. Okay, in our case is xn lah kan. All right. So now let's we continue. Okay. We go to the example, the same example, but the way question now is different. I want to find the last data, the missing data, but the data is the last. All right. So as usual, we need to obtain the table for Newton backward different. We need to use the different formula, backward different formula. We need to find R. R is a xn plus RH, okay? Is a x minus xn divided by h. What is h? H is a size of interval, is familiar. And then after getting the formula of P4x, you can use this formula to find the missing data ln 1.7. All right, you can press your calculator. Which one very good? All right, is it Newton backward is familiar? So come on, we write the data. Okay, from given xi, x0, x1, x2, x3, x4, y0, y1, y2, y3, y4 given in the question. You need to find, okay, backward del 1, backward del 2, backward del 3, all right, and backward del 4. You need to find the last, okay, row is a backward y4, backward y4 order 2, backward different y4 order 3, backward order 4 y4. All right, so this is the last row. So why? Because your triangle is a backward down. All right, so now I'm creating backward down. All right, down again. All right, down and down. All right, so this is the way. The pattern is still backward different order for yn. So we want the last, we want the value d, we want the value g, we want the value I, we want the value j. All right, D, G, I, J. This is very important because that will be representing delta 1 y4, delta 2 y4, delta 3 y4, delta 4 y4. All right, so we want to focus the last row, D, G, I, J. All right, come on. We want to use the table, just minus, okay, as usual. Okay, A is a 0.1883 minus 0, no divided. B is a 0.3365 minus 0.1823. C is a y3 minus y2. D is a y4 minus y3. All right, it's a 0.5878 minus 0.47. So you will get the answer is positive because the biggest minus the lowest. E is a B minus A. B is a del, okay, y1 minus this y1. Okay, come on. How we want to pronounce here? Why not y1, y2? So E is a y2 minus y1. F is a y3 minus y2 for the degree 1. G is a y4 minus y3 for degree 1. All right. So you can see here E is a, okay, B minus A is a negative. Okay, F is a C minus B. The data at the previous times, okay, time step is a negative also. And then G is a D minus C. All right, D minus C. All right, so the data is also negative. Okay, and H is F minus E. F minus E. All right, so the answer is a positive. Okay, it's a positive is a positive. All right, it's a 0.0074. And then now is a J. J is I minus H. I minus H, not H minus I. Always the below minus the upper. All right. Okay, I is a G minus F, and J is a I minus H is a negative 0.0024. All right, so you can see the way I minus is similar to the Newton backward. It's similar to the example at the Newton forward. So now you know already what is delta naught y3 given in the question. Delta 1 y3, all right, is a 0.1178, all right. Delta 2 y3 is negative 0.157, is a G. Okay, delta 3 y3, okay, we want to find is a H. Okay, come on, we are referring to the table above, all right, and then delta 4 y3 is a J. All right, so you need this, okay, you need this DG IJ, you need this one because you want to create, okay, you want to obtain the Newton backward different formula. Okay, I'm stop here. I want to ask a question, all right? Okay, from here, okay, why we are focused on yn, okay, yn, why we need to focus on yn, okay. For example, delta 1 yn, delta 2 yn, delta 3 yn, delta 4 yn. Why? Okay, the answer is because, okay, we are using backward different formula. We start the data from x4, the last data, okay, from xn. All right, so we need to find the last data. We will need to find the last data. All right, so now we continue. Okay, I think the answer is similar to the Newton forward, but the arrangement is different, kan? So P4x equal to P4x plus RH. All right, R delta 4, okay, R plus 1 divided by 2 factorial delta 2y4, R plus 1, R plus 2 divided by 3 factorial delta 3y4 until the last is R plus 1, R plus 2, R plus 3, all right, divided by 4 factorial delta 4y4, or is here DGIJ is given, is getting from the table. So you replace, when ln 1.7, you replace x equal to 1.7 to the formula. All right. So you need to find R first. 1.7 minus 1.8, because x4 you need to find the close to 1.7 is 1.8. Is a 0.1 divided by 0.2 is a negative 0.5. All right. So you choose x4 near to 1.8. Okay. In front of the 1.8 is 1. Okay. In front of the 1.7 is 1.8. So you fix in the formula. You replace all R as negative 0.5. You replace H, okay, X as a 1.7. All right. You insert the value. Delta 3, delta 2, delta 4 is already get from the table. All right. Fix all the formula. R is negative 0.5, 0.5 times 1.5 divided by 3 factorial times delta 3y4. And then the last part is a negative 0.5. So you can see the way of the expression is similar. Now you need to plus, okay, negative 0.5 plus 3 is a 2.5. All right. So it's a similar. The pattern is similar. All right. Divided by 4 factorial, you can get ln 1.7. Sorry, ln 1.7 is 0.53707. All right. So can you press your calculator? What is ln 1.7? Press your calculator. What is ln 1.7? Is it similar to 0.5307? Right? And then find the error. Find the error. We call as an absolute error. What is the absolute error between ln 1.7 and then ln 1.7 that we get from the Newton backward? Find the error, calculate your find the error. So you can see that here your friend said that ln 1.7 is 0.5306, but the value that we get is a 0.5307. So the error is a 0.001. Very little, very minimum. All right. Okay. So very good. This class, very good. Okay. They are listening. Okay. They are using my YouTube to find it. All right. So what is the difference between, again? Okay. Again, what is different between forward and backward? Forward to find the value of missing data early, okay, the early near to S0. And then if the data is, okay, missing data is near to Sn, the last data, you need to use backward. My question, if the data is center, so what should you do? You can use backward, you can use forward also, all right, because the data is center. It's not near to the S0, it's not near to the Sn. All right, so now my question is that I said that if I want to find, okay, ln center, the center one is the center data of the table given. Okay, all right. So what should I do if the data is a location is a center? So what should I do? The data at the center. So I said that you can use forward, you can use backward. You cannot use divide because divide for the non-uniform data. This is a uniform data. All right. Okay. I takes you too much time. All right. So I told you just now, I want to give you a simple quiz. Don't worry. Okay. This is just for my record to make sure that you what? You are following my subject. If not, okay, I just want to make sure also, all right, you are applying the student-centered learning. Okay, go to the, okay, the Google form here. Okay, you can click here to the Telegram, or you can go to the here. All right, go to your Telegram, click. All right, I hope you can get the question. Okay, come on. If I can share the screen, I share the screen. All right, I go to the share screen. I go to the okay. If I can go to the form, I can go to the form. Okay, come on. I go to the form. This is my question. Okay, my question is, you can see here. Okay, my question is, okay, I go to the Google form. What types of data for Lagrange interpolation and Newton divided formula? I give you this question. All right. Okay, what is that? Okay, what is that? All right. And then here I said that from the formula above, okay, how to generate P3x, P3x, okay, which is the formula is order 3. What is different between Lagrange interpolation and Newton divided interpolation to solving this problem? What's wrong? Okay, which one is wrong? All right, so come on, answer your question. All right, I'm waiting you at the Google form. I'm waiting you at the Google form. Okay, Mike, you need permission. Oh, you need permission. All right, I go to the permission. Send. Okay, maybe via email. How to do that? Okay, I just click. You need a permission. How to? You need a permission. How about this one? Okay, how about this one? Also, this one you need a permission. You can try. How to reduce the permission? Setting. Oh, sorry. Okay, come on. Okay, save. Okay, I need to do it again. All right. Okay, I go to the setting, respond, collect the email, edit, you cannot edit. Okay, save changes. Alright. Alright, so you go to the, I'm sharing. Alright, permission, stop sharing. Okay, I go to the Google, I go to the e-learning. Right, I'm setting my, no. I go to the stop sharing. Okay, I go to the notes. Okay, where is the notes? Report. All is the notes. Okay, I go to the PDF file. If I can open my PDF file. No, I open my PDF file, chapter 3. Alright, so yes, I share chapter 3. Alright, so now we go to chapter 3. Okay, you find here we already learned about the Newton divided Newton formula. I'm setting. Okay, we go to the exercise here. Let's go to the exercise. Alright, we go to the exercise. Okay. Come on. Okay. Okay, good luck. Okay, you can try to answer the question, right? Already on. Okay, good luck. Okay, go to the Telegram. You can see. All right. Since I'm waiting you to answer, if you have any question, come on. If you have any question, okay, this is a question. Good luck. Okay. Bye bye. See you at the Google form. Okay, all respond already. You want to see the answer? I stop sharing. I go to the Google form. All right. I still go to the Google form. Right. All right. Stop sharing. So this is one of your answer. All right. I'm waiting from you. These are people who are answering my question. Okay. This is considered as your attendance. Okay. This is considered as your attendance. All right. Okay, come on. Once you answer, this is considered your attendance. Now 22 students answering the question. Very good. Okay, see you at the Google form. Bye-bye. Bye-bye. See you at the Google form. Bye-bye. Okay.